This is pre-calculus, chapter 4.5, inverse properties of logarithms. So we've talked a little bit about logs and how to rearrange them. In 4.4, we dealt with some properties of logarithms, multiplying, dividing logarithm to an exponent. Now we're going to talk about how to actually use some inverse properties. Remember that when you do an inverse, it undoes the operation. So here, if you have log of base b and you have to the b, those actually cancel out. So it equals only whatever that exponent there was, which in this case is x. The same thing here. So you have b to the log base b. Those cancel and leave just this piece, which is x. Okay, so we're going to take a look at how we can use these to solve some problems. So here is log base 8, and there's an 8 there. So those cancel, and then that means that we're left with just 3x plus 1. Okay, so let's simplify this next one. So here's log base 5. In order to simplify it, I need to get this to have a 5 in it. Well, I know that 5 to the third power is 125. So now I can rewrite this as log base 5 to the third power, and those will cancel. So my answer then will just be 3, or when I simplify it. So let's take a look at this. This 2 and log base 2 cancel and leaves us with 27. Log base 3 and 3 cancel and leaves us with 11. Log base 3, and then I have an 81, so the same thing. I know that 3 to the, fourth power is 81. So now I can cancel those, okay? And I'm left with just 4. Okay, this 5 and the log base 5 cancel, and I'm left with just 10. Okay, so you really need to get to know these inverse operations, and remember that inverse operations always undo an operation. Okay, in other words, they cancel each other out, just like multiplication and division cancel each other out. If I multiply by 2 and then divide by 2, I'm left with the original answer. Okay, so we have the same thing when we're dealing with the natural log, or e. So remember, we talked about our base e, and the natural log is the opposite of that. It's the inverse. So they cancel each other out. So if I have an ln and an e, they cancel each other out. So I'm left with just negative 2x. Same thing here. I have e to the natural log of x minus 1. The e and the natural log cancel each other out, or ln. So here I have e to the 5 ln x. Well, I need to rewrite that because this e and this ln of x are not next to each other. So I'm going to have to rewrite that using my properties of logs. So it's going to be e to the ln x to the 5th power. Now I can cancel that e and that ln, and I'm left with x to the 5th power. So make sure you remember these rules. They're very important because we're going to start solving problems using these rules in just a minute. So let's talk just a little bit more about logarithms before we get into the actual solving problems. So it says the equation of the line of symmetry for the graph of a function and its inverse, remember, it's just y equals x. Okay. So the domain, well, so let's remember that we started out with an exponential function, a to the x. Okay, that exponential function looked like something like this, and it crossed at 0, 1. Well, remember that log is the inverse of exponents. So my log function, okay, so my log of x is going to look something like this, okay, because I'm making a mirror image over that line, y equals x. So the domain of my log is 0 to infinity. My range is negative infinity to infinity. The equation of the asymptote, in other words, where will it never touch, is x equals 0. The coordinates where it crosses the x-axis, so in my exponent, it crossed at 0, 1, it crossed the y-axis, but here, now that I've done the inverse, okay, made a reflection, remember a reflection changes your x and y values, so now it's going to cross the x-axis at 1, 0. And for all log functions, the log of 1 is always 0. And the reason for this is because you have log base 10, 1 equals 0. So that means that 10 to the 0 power equals 1, right? So we're rewriting it. Okay, so the log of 1 is 0. So we're going to actually start solving problems with this. So with logs. So it says solve the following equations for x to 2 decimal places. Show your work. All right, so the very first thing here, okay, just like any other function, we have to get our variable stuff by itself. So we have to get that e to the 5x by itself. So first we're going to divide both sides by 3. And that leaves us with 2,000 equals e to the 5x. Now this is where those inverse operations come in. Okay? So I know that to get rid of this e, I need to put natural log and raise it to the e to the 5x power. Same thing here. Whatever I do to one side, put a natural log, I have to do to the other side. So that's going to cancel, and I'm going to be left with just 5x. Now for ln of 2,000, I'm just going to plug that into my calculator. Okay, so I'm just going to use my ln key here, right there under my log, ln, and I'm just going to type in 2,000 and equals, so 7.601. Now I can finish solving it just like any ordinary equation, divide both sides by 5, and I get x equals approximately 1.52. Okay, so let's take a look at this next one. Okay, so this next one is the same thing, okay, except for this one, I'm going to have to rewrite it as a log. Right now it's written as an exponent. So to rewrite it as a log, this and this change places. So 0.1x equals log 8, base 8, oops, and I meant to make that a longer tail of my 5, okay, 7,500. Okay. Well, now I can solve this. Remember that change of base formula. Write this in a different color so you see. So that change of base formula says that if this is not a 10, I can enter it into my calculator like this and divide one by the other to get a decimal. If I enter that into my calculator, make sure you close your parentheses after this 7,500. Then I get 4.2909. And now I'm going to divide both of those by 0.1, and I get x is approximately 42.91. So we're going to solve problems using log, just like we would any other problems. Right? So in this case, I was able to punch these into my calculator pretty easily. Okay? These next ones, I'm going to do the same thing, but I might have to rewrite them. I might have to use inverse operations to get rid of some parts. I might have to add them together or separate them and do it that way. So, and use some of these properties that we've been talking about. So let's go ahead and do log base 3 of x minus 5 equals 2. I'm going to go on ahead and I'm going to rewrite this as an exponent. Okay, because I know that 3 squared is 9. So now I have 9 equals x minus 5, and I'm going to add 5 to both sides, and I get 14 equals x. Okay, so that one wasn't so bad, but I had to rewrite it as an exponent. Okay, this next one, the first thing I see here is I see 2 logs subtracted from each other. My properties of logarithms say that this is really the same thing as log of 45x over 3 equals 1. Well, what's 45 divided by 3? 45 divided by 3 is 15. X equals 1. Okay. Now, there is nothing written down here, so remember that that really means that it's a 10. So now I can change this to exponential form. So 10 to the first power equals 15x. Okay, 10 to the first power is just 10. So now I'm going to divide both sides by 15. And I get x equals 2/3, or about 0.67. Okay, the next one, I don't see any inverse operations. Okay, so the first thing I'm going to look at is if I can change that to exponential form. So I'm going to have 6 to the negative 1 power equals 2x minus 1. Well, I don't like negative exponents, so I need to get rid of that. So I'm going to have 1 over 6 equals 2x minus 1. Now I'm going to go on ahead and solve it. I'm going to add 1 to both sides. And this one has to have a common denominator, so I'm going to make it 6 over 6. So now I get 7 over 6 equals 2x, and divide both sides by 2. And remember, dividing both sides by 2 is the same thing as multiplying by a half. You guys have to be proficient using fractions, okay, and understanding that. Dividing by 2 is the same thing as multiplying by its reciprocal, which is 1/2, right? So if I wrote this as divided by 2 over 1, I would multiply it by the reciprocal. So now that's going to give me 7 over 12. And that's my x value. Okay, let's take a look at the next one. Why don't you guys try this one? Okay, at least try to get it started. Okay, see what you get. Pause the video and restart it here in a minute. Okay, so I notice that it's the same base and there's a subtraction sign. So then I know it's log base 4 of 100 divided by x plus 1 equals 1. Now I'm going to change it to exponential form. So 4 to the first power equals 100 over x plus 1. Now I can start solving this. So x plus 1, I need to multiply x plus 1 on both sides. So I'm going to wind up with 4x plus 4 equals 100. Subtract 4 from both sides. I get 4x equals 96. And divide both sides by 4. Okay, so I get x equals 24. Okay, so once you get it into a form that you're used to using, then you can just solve it like normal. Okay, but we have to get rid of these logs first. That's our first thing that we have to do, always. So here I have log base 5 of x to the 4th equals 8. I'm going to change this. First, I'm going to move this 4 out to the front, so it's going to become 4 log base 5 of x equals 8. And now I have to get all of this stuff by itself. So I'm going to divide both sides by 4. And I get log base 5 of x equals 2. Now I can rewrite it as an exponent. So now I'm going to have 5 squared equals x, which means x equals 25. Okay, and then our last one here is addition. Okay, same base, and there's an addition sign, which means it's the same thing as x times x plus 1. I'm just going to change it just like I normally would. Okay, so I'm going to change it. It's going to become 12 to the first power equals x times x plus 1. I'm going to go on ahead and distribute this x through, and I get x squared plus x. I'm going to subtract 12 from both sides. Notice that this is a quadratic. Now I need to factor this quadratic. So now I'm going to factor this quadratic, and I'm going to get x. Here, I'll show you the factored form first. So I get 0 equals x plus 4, x minus 3, which means x equals either -4 or 3. Now keep in mind that our domain for log is positive numbers, right? It's x is greater than 0. What that means is